Well, here it is. I hope you've done some homework. Here's your practice test. I want you to fill in this first sheet here. I'll put mine in. Here you are. Put E in here. Don't have a stage number, mate. Too old for a stage number. So let's come down and have a look at the first question. What I want you to do is to pause the presentation and at your own pace do each question. But you'll get an idea. In SACE you have 1.2 minutes per mark. So this is a 46 mark test. It's going to take you, how's your maths? About 55 and a bit minutes. So have a look at the number of marks for each question. There's 4 marks. That'll give you an idea about 5 minutes to do this first part. Okay, so pause the presentation, have a go. I'll take you to the next question now. Let's go through and come down to question part B. Okay, 2 marks, about 2.5 minutes. Question 2. Hope you remember some of this stuff, otherwise you're not going to give me any marks, are you? Okay, here's question 3. Okay, question 4. Question 5. Question 6. Question 7. I'll just show you the mark in a minute for part C. It's just off the screen there. There we are. And part D. Need to use a grid for this. If you're not doing it in OneNote and writing on the screen, you need to put it on a grid paper. Okay. And the last question is question 8. And it's worth 12 marks. Okay. All right. Okay, stop now and come back and let's have a look at the answers and watch me do the problems now. I'll go back to the beginning. So I filled in my name there. That's good. We know whose this work is. There we go. Let's hope I don't lose any marks, eh? So here we are. Convert the following angles to degrees or radians. What are you going to do? You're going to use the equivalence that pi radians is the equivalent to 180 degrees. Okay, so let's have a look at the first one here. 3 pi on 5. And that's going to be 3 times 180 on 5. What do you reckon? You need a calculator for that? I don't think so. And it's 108 degrees. Okay, put the units there. Usually with degrees we put the degree sign with radians because it's a ratio, arc length over radius. We don't do that. Okay, what about neg 3.28? No units mentioned here, so it's assumed it's radians. So what are you going to do? Well, it's neg 3.28 pyths of 180 degrees. Okay, taking that fraction of 180 degrees, and it says up here, watch out here, 4 significant figures. That's unusual. So we'll put approximately sign because we're going to truncate the decimal here. So it's neg 188.9 degrees. Check that one out. Have to work fairly quickly here, don't you, for your 4 marks. And so here we go, part 3, 295 degrees. So what is that? Well, that's 295 1/80ths of a pi. So it's more than a pi. You don't want too many pies, mate. You're going to get fat. So this is 1.64 pi, and that's going to be approximately 5.149 on the calculator. All that stuff's on the calculator, of course. So we should put in brackets here 4 significant figures. Unusual, SACE and IB really require 3, so it's a bit of a tricky in here. So make sure you're reading the question. So let's look at part 4. And part 4 is neg 27 degrees, so it's neg 27 1/80ths of pi, all on the calculator now. So that's approximately neg 0.4712. Okay, do it on the calculator, 4 significant figures in brackets. So this is do or die, this question. You don't need to put 4 significant figures in brackets. You don't need the approximate sign. Technically you do. We're not going to penalise that now. But it's sudden death. It's 1 mark for those final lines with the significant figures. So what I'm going to do when I mark this stuff, I'm going to actually give you 1 penalty point if you missed all of them at 4 significant figures, only 1, and then mark correct to whatever you've done, the other ones. So Yeah, it's pretty sudden death. A lot of work there for 1 mark. Okay, how'd you go? Make a mark out of 4 down the side here. Okay, let's go down and have a look at question 2. How are we going for time? I want to speed up here, I think. Use the unit circle diagram below to illustrate the angle in part 2. Well, hang on. I've forgotten what the angle in part 2 is, mate. Let's go back up here. The angle in part 2 is neg 3.28 or neg 188.9 degrees. Well, I think 188.9 degrees is easy to think of. Just watch the negative, though. The negative. Do you remember coming around the unit circle now? Negative is in this direction. So neg 180 is over there, and it's about 8.9 past. There's a bit of a guessaroonie here, mate. So it's there somewhere, you reckon? Or out like that. Okay. So there's 2 marks. Now, what's the 2 marks for? Well, first of all, indicating the negative direction, right? That's 1 mark. And then landing it in this quadrant, and not too far in, because only 8.9 degrees into that quadrant, right? Got it? Okay, so mark that out of 2. Okay, let's move on. We've got to keep going here, mate. There's a lot of questions coming up. Okay, question 2. Find and search for the possible values of sine theta of cos theta equals a fifth. I wonder if you remember this. Okay, sine squared theta plus cos squared theta is 1. Established on the unit circle, if you remember that. So what we're going to do is we're going to say that cos theta equals a fifth. Therefore, sine squared theta plus 1/25 equals 1. Sine squared theta equals 1 take a 25th, which is therefore 24 25ths. Okay, implied sign down here leading through an equation statement. So sine theta, quadratic, 2 solutions, plus or minus root 24 on 5. Okay, these are 4 marks. So there's 2 marks for each of these. The first mark is to get to this line, okay, 1 mark, and then the plus or minus statement there, the other mark, okay, so pretty easy to do your marks here. So in part B, sine theta equals neg 2/7, so it's going to be neg 2/7 squared plus cos squared theta equals 1. So the cos squared theta is going to be 1 minus 4 on 49. So cos squared theta is going to be 45 on 49. And cos theta is 2 solutions to a quadratic, plus or minus root 45 on 7 will do. Don't have to tidy that up because you're only going to get paid for that and that. Okay, so you've got a total out of 4. How are you going? I hope you're getting some marks, mate. The real test is coming up on Monday. Okay, so here we go. State the working angle for theta in the following and hence find the exact value. All right, well, I reckon here it's 6 marks, so it's 3 each. So I think what you should do first of all is find what quadrant you're in here. So this is neg 5 2/3 pi. We want to find a working angle, an equivalent angle in another quadrant. So let's go around the unit circle here. It's a bit of a tricky do, this one, because it's negative. Okay, so let's go around 4 pi. So that's back to here, isn't it? We're coming around this way. 1 revolution is 2 pi. So 2 revolutions are 4 pi, and we've got neg 5 2/3 pi. So we're going to want to go around here a further neg 1 2/3 pi. So where are we? Well, here's neg pi to here, coming back this way. And 2/3 pi would land us in here, wouldn't it? Right around there would be neg 1 2/3 pi. So this working angle is pi and 3 off a whole revolution. Whole revolution there would be in that quadrant with 3 pi and 3. So we've got a pi and 3, so that's our working angle, so get you 1 mark for that. And you want to find the exact value of the required trig ratio. So the sine of pi on 3, it's landed in the first quadrant. The sine of pi on 3 is root 3 on 2. Okay, so they are values that you should memorise or at least have on your hint sheet. Okay, those common angles. Let's do the same thing over here. Now, we're not going to be in this course doing much with degrees, so this is a bit of a furphy really. But neg 225, let's find it. This is neg 180, and we want to go 45 more, don't we? So we're going to be right in the middle of that quadrant there. Actually, 45 past neg 180. So what's the equivalent working angle in the first quadrant? Let's draw our congruent triangle so the x and y values match up. The equivalent working angle is 45 degrees there. However, it's the cos, and what do you notice? The cos is the x value. So the cos of neg 225 is going to be minus or negative the cos of 45. So it's neg root 2 on 2. Did you get it? Okay, one for what? Locating in this quadrant. You're pretty hard earning marks here. And then one for the equivalent angle and one for the answer. Over here, same thing. One for the quadrant, one for the working angle, one for the answer. Total of 6. How you're travelling, I hope you're scoring some marks here. So let's have a look at the next question. Question 4. Question 4, was that easy peasy? Oh no, look at this. What are they doing to you, mate? I guess you didn't even know what that meant. Oh well, better revise that. Here we go. Possible exact values of theta if cos theta equals -1/2. Okay, what's the process? The reverse process of what we just did. Can you find a working angle whose cosine is 1/2 in the first instance? So that's pi on 3, isn't it? Okay, you're supposed to memorise that. Cos of pi on 3 is 1/2. So can we now find all those angles, exact, here we are, so it's got to be in pi land, and all find the possible values, see the plural there? And let's draw a unit circle and find where they are living, those angles with the equivalent cosine. So they're multiples of pi on 3. Let's draw pi on 3 in the first quadrant. That won't do, will it? That won't do because its cos is positive. We want some negatives, so let's go to the quadrants where cos is negative. That's the x value. So here's one over here, so we'll make a congruent triangle here. That'll be pi on 3. And make another one down here. This is x is going to be negative here as well. So we want those two positions. But look at this problem. We have to express one revolution as a negative section and a positive section. Let's do the positive section first. We got this little dude in here. This one here, going around to there. So what's that? Pi take pi on 3. Or 3 pi on 3 take pi on 3. So it's 2 pi on 3. And around here, in negative land, this is neg pi here. We're coming back pi on 3. So it's neg 2 of pi on 3. Okay, you state those in any order. Or plus or minus 2 pi on 3. Okay, how are we going to mark this? Well, there's going to be one mark for saying I want an angle there and I want an angle there. And one mark for writing them correctly. Okay, this really is probably a 4 marker. Okay, well, that'd be a bit hard on you. Budding young mathematicians, you've got to do it hard, mate. Okay, so here we go. Question 5. Briefly explain why sine of 195 equals neg sine of 15. Well, I wouldn't have a clue, eh? So I'm going to draw a picture. Okay, so here we go. We've got our unit circle. Where on earth is 195 degrees? It's 180, and it's 15 into this little hole here. It's 15 in there. So you know, let's try and relate it to an angle in the first quadrant, a working angle. We've just done it, haven't we? It's a working angle of 15 in the first quadrant because of congruence. Okay, these two triangles are congruent. They have the same size y's, the same size x's. But let's have a look. 3 marks. What do you have to do? Well, first of all, you have to state that you're going to link it up with a working angle in the first quadrant of 15 degrees. That's 1 mark. And then you need to say, well, the sine of 195 is the y coordinate of that point down there, okay, and that is going to be equal to the y coordinate of 15, but negative. So we'll put that in there, a negative y coordinate of 15. So that's your final thing there. Okay, so first of all, relate it to a working angle in the first quadrant, state that the sine is the y coordinate, and that the relationship in those two triangles is that's a positive and that's a negative. In any ways you want. Perhaps you won't do it as mathematically as what I've done, but that's what I'll be looking for. Okay, let's go on and have a look now at question 6. Easy peasy. Did you think so though? I wonder. Get rid of these degrees later on, because in specialists you don't actually use degrees much at all. Okay, so sine 60 cos 60. Evaluate as an exact answer without using a calculator. So what you need to see here, what the marker needs to see, is a careful replacement of sine 60 by root 3 on 2 and cos 60 by 1/2. That's got to be shown. Show all your working there. See that? Okay, so this is eventually root 3 on 2. Decimal equivalents won't do because it said exact answer. There's only one exact form for the irrational number root 3, and it isn't 1.732x, etc., etc. It's got to be root 3, okay? So that's 2 marks. So first of all, correct substitution, 1 mark, and 1 mark for the answer. Let's have a look at this one over here, and I wonder if you did it hard or saw what was going on. These two angles are the same, see that? Neg 7 pi and 3, that's ugly, I don't want to do that. Neg 2 1/3 pi, that's ugly. I don't have to do anything with it because it's cos squared of that angle plus sine squared of that angle. And you know that the sine squared plus cos squared of the same angle is 1. Let's go back to the unit circle and just prove that. Here we are, you know, this is not for marks, this one. But here, when we defined and extended SOHCAHTOA into that unit circle, what do we see? We said that the opposite over the hypotenuse of 1 was the sine, and that was that coordinate, and this was the cosine. But Pythagoras still reigns supreme, mate. X squared plus y squared equals 1 in a unit circle. Therefore, cos squared plus sine squared equals 1. Remember that stuff? Okay, so there's 2 marks here. 2 easy marks if you spotted it that way, just writing that statement down. If you did it hard and went to 7 pi on 3, which is 2 1/3 pi, come around here, and neg 7 pi on 3, well, that's doing hard. It will still come to 1, but that's hard work for you. Try not to do hard work. Try not to work at all. It's all too hard. Okay, here we go. So let's go down to number 7. Okay, 7 is a modelling problem, but the model's been set up for you. Now all you have to do is use it. Now please keep your wits about you here. No one says without using a calculator. Okay, so the first thing in these sorts of subjects where you're allowed to use technology is the rule is don't do maths. Always run the technology first, right, if you possibly can, because it's a test and you want maximum marks. I'll do it both ways now. So first of all, having a look at the rest of the question, it's going to be useful slapping this dude on the calculator. Just keep in mind a couple of things. You're going to go to graph mode, you're going to go shift menu for a start, well, after that anyway, to set up, to make sure you're setting the calculator up in radians. So you scroll down to angles, see these steps here I'm putting in, and make sure it's rads, not degs, because this 2 pi t on 3 is going to be in radians as designated by the pi there. Okay, so slap it on the calculator, and then you can G-solve it. Okay, so you could go shift now, F5, or hang on, you haven't got the picture yet, have you? Okay, make sure the graph is on the view window. So the syntax, what's the syntax here? You've got to have sign of a bracket around that there. And then you could go shift F2 and go zoom auto and make the calculator find it for you. Because look at these numbers. So you see these numbers here? What's the maximum minimum value of that function? Okay, so it starts pretty high up. It starts at 20. If you go view initial view window, you're not going to have it in there. So you need to have some strategies. You're either going to try and work out where it's lying, which might be a bit hard for you, or shift F2 go zoom and auto. Okay, and then you're going to go shift F5 to G-solve. The option you're going to choose, which is a misnomer actually, is root, because you want the root of the equation where this function no, you don't. You want t equals 0. So we have to go across to the next window and pick a y calc for x is equal to 0. And if you do that, then you get y is 20, and that won't do. That's a technology answer. You must say the height, I'll give the answer in the context of the question, the height is 20 metres. Okay, so that's the way you probably choose to do it. Let's just check algebraically, because I think algebraically might be a bit quicker. You're going to sub naught into this doofy. So this is minus 19 sine of naught, isn't it? Sine of naught is naught, so it's 20. Okay, so that's quite quick there. Now the next answer is not so quick, so you might as well have spotted the whole question, drawn the graph, so you can just cruise through the whole thing straight with technology. So at what time is the light at its lowest? In the first revolution of the wheel. Okay, so you're going to find the lowest, that's the minimum. So again, G-solve it, shift F5, go to min, and read it off. And if you do that, it's t equals, or x equals, and then you must change it the context of the question. 0.75 or 3/4 of a minute, complete with units there, because the x-axis there is in minutes. Read the question up here, look at this, metres and minutes, so watch that. Okay, that's important, that's worth a mark. So let's start marking this. Obviously you've got to get the 20 up there. I'm not going to penalise the metres, but you should. There's only one mark though. 2 marks here is really just paying you for the work you have to do in entering it on the calculator. So the one answer will give you the 2 marks there. How generous is Huddy, eh? Anyway, part C, we've got how long does a wheel take to complete 1 revolution? Okay, so let's do that 2 ways. Let's first of all do it, and I'll get rid of that. Let's first of all do it with Shift F5 with technology and read it off there. You want here the distance between successive maxima or minima. Okay, and if you do that and read it off, you get t equals 3 minutes. Now, to complete 1 revolution, that's coded for the period, isn't it? The period of the function. Okay, complete 1 revolution. Okay, so 1 revolution, where's our function up here? What is it? 2 pi 3 times t. And the period is 2 pi over b, isn't it? The coefficient of t there. So what's this now? This is lovely little stuff. 2 pi divided by 2 pi on 3. You're screwed on this one, mate, because you've forgotten how to divide by a fraction. Let's have a look. So it's 2 pi divided by a fraction. You invert and multiply. Hey, it works. This is magic. Maths is magic, mate. So there it is, done algebraically. Could you do that? You didn't have to here, because no one's making you do maths in this one, but I think you should be able to do that. Okay, so that's 2 marks as well, and that's mainly, you don't need this at all. All you need is this over here for 2 marks. Okay, sketch the graph. Now, this is very, very important in both specialist and studies now. It's usually, I've made it 3 marks, and you should know what those 3 marks are for. There's 1 mark for labelling the axes, both of them, showing the scale and the units. Hey, it's easy to blow this mark, mate. Okay, if you don't label an axis with height, in brackets metres, or don't show an adequate scale, any of those loses the mark. So there are 6 points here that the markers use. 6 points to get that 1 mark. Any one missing, you blow the whole mark. Okay. The next one is for key points on the curve, right? Maximum, minima, intercepts on axes and things. And the last one is for the shape. Now, this is classic. If they give you, and they do tend to do this in studies but not specialists, if they give you the scale all set up, then it's only 2 marks because they've done a lot of work for you. So here you are, I'm going to try and draw one here. Now, I'm not able to get a ruler. Hang on, see if I've got a ruler here. No rulers, mate. Okay, so what I'm going to do is I'm going to do it by hand and see how good we can go here. You should rule it up. I have come ill-prepared, bad student. Okay, so here we go. Let's have a look down here. We're going to draw a vertical line here, and we're going to label it H, in brackets metres. All right, and now we need a scale on it, and you can't just put scale divisions, because you've got this on your calculator. We know you have. And all you're going to do is whip a quick sketch off of your calculator. You don't actually know anything about it. You just can see the squiggle on the calculator. So you've got to prove you know something about it. So let's have a look here. 10, 20. So I've got to at least label one of these marks, because it could be going up in 1s, 2s, 5s, whatever. 10, 20, 30, 40, 50. Okay, so I've got that scale. I still haven't got a mark yet, mate, because I've still got to do this axis. See that? No ruler. That's crap, mate. You've got to get rid of that. Okay, so along here, this is time in minutes, and we've got to have a scale. So what I'm going to do is look at the graph on the calculator, and I'm going to make this into 4s. You'll see why in a minute. 1, and then 1, 2, 3, 4, 2, 1, 2, 3, 4, 3. Okay, so that looks pretty good to me. Okay, so everything's ticked off. That's 1 mark I've got so far. Okay, now let's put on some of the easy peasy things. This is the key points. Now what's a key point? Well, where the thing started, mate. They asked us here at t equals 0, so that's 20. Okay, what's the next thing I want to do? I probably want to go down and show where it was a minimum, and that was back up there, 3/4 of a minute. So that's that point. They're going to mark this, and then the next one is the maximum. So I'm going to have to G-solve something I haven't been asked earlier in the question, and that is G-solve for a max, which is going to give me 2.9, I think it is 2 point, just in here, let's have a look straight off the calculator, and the maximum there is 39, hang on, I've got to find it up here, 39 there, okay, we'll just get rid of that. And it's got to be about here, 39 there, okay. So you can't get it accurately here, but it's got to be within a scale, within a square, is how they mark this now. So that's 39. See, this is 40 here. So it's got to be under 40 and just past the 2 there between those two. Just come across a little bit here, because that'll be all right, but it should be within 1 square of the proper answer. And then what do we want to do? I think we have to put it a whole revolution just there. We said 1 revolution took 3 minutes. Okay, so now we're going to draw it. So that's our mark for the key points, and we're going to go here, up here, so the shape has to look approximately correct. Okay, so see this here, this is a bit straight. I don't actually like that, because that's not the classic U shape of the sine curve. It should be more like this. Right, so I'm going to rub that out and have a better go there. Okay, so you want to take a bit of time for this. This is a mark. So what are they going to mark? This, you could call that a key point, because that's on the principal axis, but that wouldn't be marked here. What they'd be looking for, did it start correctly here? This is approximate, and here. Has it got the symmetry and the U shape of those 2 arches in the sine curve for that last shape mark? So you're working pretty hard, because 3 marks is 3.6 minutes in SACE, and yeah, there's a fair bit to do there. You might time me. Did you run the clock on me and see how long it took me to do it? Okay, let's have a look now. Come down to the last question. Okay, so this is a classic modelling question. We're given a set of data, so you can do this by hand, but it does ask us later on. Here it says without using technology. It does ask us later on to actually check it with technology. So let's start without technology. What are we going to do? Well, with modelling of this type by hand, it's fairly rough. We want to ascertain first of all the maximum. Okay, what's the maximum? Let's go along here and we see it's in the month of July, 7th month, and the maximum is 27. The minimum here, so this is Northern Hemisphere, right? Greece, see that? So the summer is in June, July, August, and where it's winter here. The minimum, okay, where's our minimum? Is 214. And so what we want is, what are we going to do first? What do you reckon here? I reckon I want to go for the amplitude, eh? So the amplitude is what? Well, the gap between max and min divided by 2, isn't it? 7 take 2, okay, over, oh, hang on, I put the wrong numbers in here. 27, the y values, mate. The y values, 27 take 14 over 2, which if you do it on a calculator, is 6.5. Okay, what about the d value? The translation of the principal axis, right? The d value is halfway between the max and min. What's halfway between 2 scores, mate? Oh, yeah, that's a mean. So it's 27 plus 14 on 2. And if you do 27 plus 14 on 2, you get 20.5. Hey, we're going pretty good. Okay, we've only got a couple of variables there to work out, or coefficients to work out there. Okay, so let's go for B next. Now we know the period is what? Well, I would say, having a look at the numbers, it doesn't perfectly work out that the 16 is repeating or it's going to be back to 15 or whatever, but we'll go on a little bit of knowledge here that seasons are all fit in 12 months. So the period is going to be, we're going to say it's 12 months, even if the data doesn't actually support that perfectly, okay, because there could be errors in measurement there. All right, so here, period is 2 pi. So we know the period is 2 pi over b, and therefore 12 is 2 pi over b. You've done this so many times, multiply across, and so now we've got b is pi on 6. Pretty common one for all those things seasons and stuff that occur in 12 months with a period. Okay, so that's good, but now what are we going to do? We've got to find this C value, the translation. So let's go through a little bit of this. And I'll just come down here a bit to get a bit more room here. So just remember what a sine curve looks like. Okay, sine curve starts like that. Okay, and starts at 0. Now, if you have a look at our curve, and you haven't put this on the calculator yet, it doesn't start at 0. And so what we need to do is to say, well, okay, it starts somewhere down here and goes up and so on. Okay, so what we want is we want to find this distance, so we put this as t and little t. We want to find how far in that's been translated before we get that first arch going to a maximum. So let's go up to our data and see if we can find that now. Okay, so in here, somewhere between the 4th and the 5th month, it's somewhere, 5th month there, I'll circle that one. Somewhere in between there is that principal axis cut, isn't it? Principal axis is 20.5. And we're not going to do it algebraically, we're going to do this by hand. We'll do some algebraic stuff on this later on. But here what we want is to say, well, this here is halfway between the minimum and the maximum. Well, is it? Where's the minimum? Let's go back here. That's in the 4th month there, 14. So this is 2nd month, sorry, February, 2, 14 down there. And then the maximum, come along here to July, is the 7th month, and that's 27. Okay. Now, if we are fitting our model religiously as we are by hand, with these as absolute maxes and minimums, that they are definitely the best way to fit it by hand, then we're saying this should be halfway in between this point. So what's halfway between the 7 and the 2? Halfway between two numbers is a mean, mate. So that's 9 on 2 or 4.5. Okay, so that's why we'd fit it here. Okay, and so we found our C is 4.5. So what's our final model? Let's write it down now. T is 6.5, sine B was pi on 6, T take 4.5, plus D, I'll find it up there, mate, is 20.5. A lot of work here, but I'm going to pay you 6 marks for it. So you still got to keep your wits about you with this, because it's a fair bit of work for only 7 minutes. Okay, so let's mark it now. You were asked to find the values, so you're going to get 1 for each of these values. 1, 2, 3. Now this, you'll get 2 for this one, for the 4.5. Where can we put this in here? Get 2 for that one. And the extra 1 is really a bonus point, because it's for putting t and little t in there and not y and x. Okay, because in modelling you've got to make it contextual. That's very, very important. And there's our mark. So did you get it? I think this C stuff confuses people a bit. All right. Let's have a look now at doing it with technology. And you'll go to, well, we've got to go here. I'll put the steps down. I'll do these. So you start, enter the data in list 1 and list 2, and set it up as a scatter graph. Okay, and then you want to go to the next window when you're doing a calc. So go calc, and next window was sine. Okay, and you're going to read the numbers just off. Now I'm going to use 3 significant figures here, would probably be best. And if you do that, I'll put it in y and x land for a start, and you read these off. So it's y equals 6.15 sine. Now, what they do here is put the b inside. So it's 0.5760 at the moment. I'll bring that back in a minute. And then it's take 2.694 and plus 20.4. Okay. So let's now change this. First of all, keep it in y and x land, 6.15. I'm going to take that b out as a factor so we can see the translation better. So taking that out as a factor, 760, it'll be x take, and 2.694 divided by that is neg 4.685 plus 20.4. Okay, now I'll tidy it up a bit and go back to t equals 6.15. Bring it all now back to 3 significant figures for 576. Little t here minus 4.69 plus 20.4. Okay, now let's mark it. Use your technology to check your answer. Okay, so what I want you to do is to mark this carefully now. There is, for just putting this down, there are going to be 2 marks for getting all the numbers right now. Okay, now to check your model against the other one, you really have to have it in the same form. So there's going to be 1 mark for pulling that out. 1 mark for pulling that out. Okay, so that you're getting this. And then 1 mark for going back to context, and that is big T and little t. And I'll just bring this down. Now we want, how well does your model fit? Okay, so we need to make some comparisons here between the other ones. So write the other one underneath here, 6.5 sine pi on 6, t take 4.5 plus 20.5. Okay, so if you then want to talk about this, then you need to say, well, this one is a little bit out. The numbers here are a little bit out. Pi on 6 should be checked. Pi on 6, and what is pi on 6? You should make some statement here. This is approximately 0.524. That's a little bit out. So they're all a little bit out here compared to up here. Okay, so you'll say it's model is a good fit. The difference going to be this is a regression model. The regression model will differ from the other, as we are assuming that the max and min, which is our model based on what our model is there, we're assuming that the max and min are perfectly correct. The regression model fits it to all points. So something like that, comparing the 2 models. I'm reading how well does your model fit. I'm comparing it to the regression model. It could be another interpretation of that question. How well does your model fit the data? No, I'm not interpreting it that way. I'm interpreting it as how does your model fit, our model there, versus the technology model. Okay, so what have we got here? You've got 1, 2, 3, 4 there, and 1 here for converting that pi on 6 to compare it to the 0.576, and for 1 statement, 1 for some reasonable statement, say, yeah, they match up pretty well. Okay, well, I hope you got some marks there, mate. Go back and total them up and see what you think. Put a total at the top here. Just at the top, where are we? Here we are. It's out of 46. I hope you remember how to convert it to a percentage. There you are. If you can't convert it to a percentage, take 1 off. Okay, well, cheers for that, and I hope you enjoy studying for the actual test now. So work hard at it.